Hey guys, welcome back to General Chemistry. What we're going to talk about now is an application to stoichiometry. So if you have not been practicing stoichiometry, I would go ahead and stop this video, go practice it, get proficient at it, then come back to this video because we're applying it now to a different type of problem. The type of problem that we're going to talk about now is something called a limiting reagent problem. So let me set up the concept first, and then we'll look at an example. All right, so we're going to go back to our really crappy pancake recipe. So remember our recipe was 1 cup of flour, 2 eggs, half a teaspoon of baking powder, and we get 5 pancakes from that, right? So let's say I go to my pantry, I go to my fridge. I have an entire bag of flour, so tons and tons of flour to work with. I'm in my pantry, so I look at my baking powder, and I have an entire brand new box of baking powder. I just bought it at the store. Then I open up my fridge, and I see that I have 4 eggs. Only 4 eggs. So if I wanted to make pancakes with these ingredients, I have plenty of flour, I have plenty of baking powder, but I only have 4 eggs, right? So what's the maximum number of pancakes that I could possibly make? 2 eggs makes 5 pancakes, and 4 eggs would give me 10 pancakes. But what if 10 wasn't enough? What if I wanted to make more than 10 pancakes? Let's say I needed to make 20 pancakes. What would I need to do in order to make more pancakes? Yeah, I'd have to get more eggs, right? So in this scenario, the eggs are what we call the limiting reagent or the limiting reactant. It's the one piece of the recipe that limited us from making more pancakes. So with the ingredients as they're written on the board, the maximum number of pancakes, the most pancakes I could possibly make is 10 pancakes. I've got extra flour sitting to the side. I've got extra baking soda sitting to the side, but I ran out of eggs. And if I wanted to make more than 10 pancakes, I would have to add more eggs to the recipe, and then I could get more pancakes out the other side. Chemical reactions work much in the same way. Okay? So a limiting reagent or a limiting reactant is the reactant that makes the least amount of product. So with a bag of flour, I probably could make like 100 pancakes. With an entire box of baking powder, I could probably make like 50 pancakes. But with the eggs that I have, the least product that I could make, or the most product I could make is 10 pancakes, and that's the one that limits us from making more. Okay. The other thing to notice in this definition is the reactant. That's important. When we're asking about limiting reagents or limiting reactants, the answer is always going to be a reactant. Which reactant is the limiting reagent? It's never going to be a product. That's our answer. We're always going to have a reactant. That's our answer. And we're always going to have a reactant that starts the problem. So we'll never start with the product. We'd always start with one of the reactants. The best way to work through this is really just to dive into an example. So that's exactly what we're going to do. Suppose we have 20 grams of sulfur trioxide and 10 grams of water. We want to know how much of the sulfuric acid, H2SO4, can be made. What's the most that can be made here? Okay. So let me just set up the premise of this problem. How are we going to solve this? Well, to solve this, we're going to have to do 2 stoichiometry problems. Okay, so the first stoichiometry problem that we're going to do is going to be with sulfur trioxide. So we're going to take the 10 grams of sulfur trioxide. We're going to convert that to moles of sulfur trioxide. Then we're going to convert that to moles of sulfuric acid. Next, we're going to do the same thing, but we're going to start with water, our other reactant. So we're going to take 10 grams of water, we're going to go to moles of water. Then we're going to go to moles of our same product, H2SO4. From here, we're going to pause. We are going to look at the answer at this step. So we'll have a number of moles of sulfuric acid, number of moles of sulfuric acid. We are going to pick the smaller one. And then we're going to complete our thought because it's likely going to ask us the answer in grams. So we're going to complete our thought, and with the smaller of those two numbers, we're going to go from moles of sulfuric acid to grams. Okay. So essentially, when we're dealing with a limiting reagent problem, we're essentially doing two separate stoichiometry problems and then comparing to see which one limits us from making more. Okay. So that's kind of the blueprint of how this problem is going to take place. So let's now dive in to the nitty-gritty. So I'm going to first do the sulfur trioxide. Okay. So I'm going to start with the 10 grams of sulfur trioxide. And I'm going to go to moles of sulfur trioxide. So grams on the bottom because that cancels. Moles on the top. And then I'm going to go a little bit faster at this step. I'm not going to write each individual piece down anymore because my assumption is that you're proficient at this. So I'm going to get the molecular mass of sulfur trioxide. So I've got 3 oxygens, so 15.999 times 3, plus the molar mass of sulfur. So go to the periodic table, and I see that it's 32.066. So down here, sulfur trioxide is 80.06. Multiply across the top, divide by the bottom. So 10 times 1 divided by 80.06. And we get 0.12 moles of sulfur trioxide. Okay. Looking at my map, I went from grams to moles. Now I want to go from moles of sulfur trioxide to moles of sulfuric acid. So I'm going to bring this down, 0.12 moles sulfur trioxide. Moles of sulfur trioxide on the bottom. That's what we're getting rid of. Moles of sulfuric acid on the top. That's our destination. And then to get the numbers that go into this step, we're going to look at the balanced chemical equation. And so everything here is a 1-to-1 ratio. So 1, 1, multiply across the top, divide by the bottom. So we get 0.12 moles of sulfuric acid. Okay. So this is that moment where we kind of pause here. Now I'm going to do the same 2 steps. I'm going to do the same 2 steps, but this time I'm going to start with the 10 grams of water. So why don't you guys go ahead and pause the video and see if you can get from grams of water to moles of sulfuric acid. All right, let me work this one out with you. So we've got 10 grams of water. So in 1 mole of water, there is 18 0.01 grams. Multiply across the top, divide by the bottom. So then we are left with 0.55 moles of water. start a new train track. We're going to go from moles of water to moles of sulfuric acid. All right, and then moles of water on the bottom, moles of sulfuric acid on the top. And looking back at the balanced chemical equation, again, everything's a 1-to-1 ratio. So 1 and 1. So we get 0.55 moles of H2SO4. Okay? And here's the moment where we pause. Okay? So now, limiting reagent. Which of the reactants limits us from making more? So in this step, we're always going to pick the smaller number. We're always going to pick the smaller number. Okay? So remember back to our example. We had enough flour to make 50 pancakes. We had enough eggs to only make 10 pancakes. That was the most we could make. Here, we have enough water to make 0.55 moles. But for sulfur trioxide, we can only make 0.12 moles. That's the most we can make right now. There's going to be water that's left over. So we pick the smaller number. Okay. When we do that, so we pick the smaller number. I'm going to go ahead and erase this just so I have some room here. So remember, when we pick the smaller number, we're then going to take that one and we're going to finish out our thoughts and go to grams of sulfuric acid. So I'm going to take the 0.12 moles of H2SO4, moles of H2SO4 on the bottom. That cancels. And then we're going to have grams of H2SO4 up here because that's what we're trying to determine. So get the molar mass, so 15.999 times 4 plus 32.066 plus 1.008 times 2. So the molar mass for sulfuric acid is 98.07. So multiply across the top, divide by the bottom, so 0.12 times 98.07 divided by 1, and we're going to get 11.7 grams of sulfuric acid. Okay, so that's our answer. So again, just to summarize, when it's a limiting reagent problem, you're going to do two separate stoichiometry problems. So you're going to pick one reactant, go to the product, pick the other reactant, go to the same product, and then compare those values. You will always pick the smaller number and then go from moles to grams using that smaller number, and that's the maximum amount that you can make. And then you can identify your limiting reagent as well along the way. So that is limiting reagents. I hope you guys found this helpful.